Hi, so welcome to our little 3-point test cross practice question that we hope will help you study for your final exam. Um, we're going to be applying some concepts that we learned in class and basically trying to do what we've been doing in class, but backwards. So instead of drawing out the gene map, we're given the gene map. The premise of the question is to basically fill out the table. As you can see, there's already a few values put in there. Just because it would kind of be impossible, at least using the means that we have, to completely fill out the table without those values. So let's get started. If we just give the question a quick read, given the following gene map for 3 genes with recessive mutations Z, A, and G, fill out the table below for a 3-point test cross for a heterozygote in coupling for all 3 genes. We also see a little note here that the dominant wild-type allele for each gene is denoted by a plus sign in the table. So, looking at the information that we've been given right off the bat, something that I would highlight if this was a question given to me on a test is that we have a heterozygote in coupling. So what that tells us is what the chromosomes look like. We know that all the dominant alleles are on one and all the recessive are on the other. So I'm going to quickly switch over to a blank piece of paper so that you can see kind of what I mean. Okay, so switching over, we have what our 3-point test cross is going to look like basically. So we know that in a test cross, the other organism is going to be homozygous recessive. So that's what we have drawn out here. We can also see for our heterozygote that it is in coupling with all of our pluses denoting the dominance on one and all of our recessive alleles on the other. And we know in the table that one of the things we have to fill out is the type of gamete. With this in mind, let's look at our options. So we can have a crossover between these two or a crossover between these two. And our double crossover will involve our middle gene, that is A. And we know for certain that A is in the middle because we are given the gene map. So now let's go back to our table and see if we can identify some of the types of gametes. So our parentals are quite easy. They're going to be our non-recombinants, and they're going to look exactly like what we saw on the previous blank slide. So we can easily identify those first. The second easiest to identify would be our double recombinants. This is characterized by the switching of the middle gene, and because we have the gene map, it's pretty easy to pick that out right away. The middle gene is A. We know that these last 4 are going to be single crossovers, so we'll highlight them in orange. And differentiating between the 2 possible single crossovers is tough, so I'm going to switch over to a blank slide. So our first possibility would be a single crossover between the genes Z and A. So if these 2 genes were to cross over, we would have the following possibilities. So our first possibility is plus AG. So I'll just write the little order down here, and then I'll switch colors, I guess, for the other one. And that would be Z plus plus. So we can go to the table and see Z plus plus and plus AG and fill in single crossover between the genes Z and A. We can use a similar idea to find that the other one is a single crossover between A and G, and also just by default it's the only option left, so we can fill that into the table, and we can move on to doing the calculations to find the expected numbers of progeny and fill out the rest of the table. So we know that our distances on our gene map are equal to our recombination frequencies times 100. So to get the expected number of progeny for a single crossover between Z and A, we see that we have 17.7 centimorgans, which are equivalent to map units. So we're going to divide that by 100 to get our frequency and multiply that by our total. The blank that we need to fill is the one that isn't already filled in, so we're going to subtract 186, which is already filled in, and we will get 168. and we can just write that into the table, and that's our first expected number of progeny blank filled. So let's move on to a single crossover between the genes A and G. So we're going to use basically the same strategy. We're going to take our 11.3 centimorgans on our gene map. We're going to divide it by 100 to get our frequency, multiply that by our total number of progeny, and subtract the number that's already filled in on the table. And then we will put that leftover number, which in this case is 105, in the blank. For our double crossover, we are going to take the recombination frequency between Z and A, which is 17.7 over 100, and then we're going to also take the recombination frequency between A and G, which is going to be 11.3 over 100. And we're going to multiply that by our total progeny and subtract the existing number, which should give us our answer of 22. And we're going to put that in the blank. So we know that we're going to use those two frequencies, right, from probability, or the chances of something happening, of one thing and another thing happening, are those two probabilities, or in this case we're using frequencies multiplied together. Now we're going to move on to the parentals. So this is probably the easiest one, and that's just because the work's already been done. Obviously, if you were to do it, the parentals first, let's say you were to do the parentals first, this is how you would write it out. So we have our total progeny minus, and I just factored out the 2000, so we're factoring out the 2000 so that we don't have to write it a bunch of times and we can save some space. And then we have our frequencies that get us our single crossovers between Z and A, and then A and G, and then our double crossover. And then we minus the blank that's already filled, which is 698, and we end up with 682. The other way that you could do this, obviously, is to just take 2000 and subtract everything that's already filled in, and naturally the leftover number is your answer, but that is all. That's the big, solved, finished question. We hope you enjoyed, and best of luck in finals.